We're going to be solving some questions on work, energy, and power. I mean, some Waec questions, Neco questions, and Jamb questions. Now, but before we go into the solving of our questions, we must look at what these concepts, what they are all about. We have work, we have energy, and we also have power. Now, we're going to begin by looking at what work is. If you must have heard people, especially laymen, a layman will tell you that work is what you do. Work is that which you do even while you're seated or while you're sitting. You can decide to carry out a particular work. But in physics, it is not so. In physics, work is said to be done when force is applied towards a particular distance. And then we have it stated as work. Picking work first. We have work is the product of force and right here and let's have here and distance in the direction of the applied force. So work is the product of force and distance in the direction of the applied force. That is the multiplication of force and distance will give us work. So we can have it mathematically. You can say mathematically we can have it given as work. Let's have W. W stands for work, which is equal to force. Force is in Newton times distance. Let's have distance times our distance. Distance, as we use S for distance, which is in distance is in meters. Let me just write the SI units. Distance is in meters. So I can have work done, or work is the same thing as. Now, sometimes they give you a question, they will not give you force outrightly, but they will give you some parameters that will help you to look for the force. So sometimes force, we can always represent force is the same thing as mass times acceleration. So we can also have it based on if the motion is linear, we can use our A. If the motion is based on a vertical motion, we can use our G. So we can also have this can also be mg. So let's have it can also be ma or mg. This can be used the same way. So we also have our distance is in meters, but we use S to represent distance. The unit is in meters, use S. So if you want to know the SI unit for this, the standard SI unit for work is joules. Work is measured in joules, but sometimes, depending on what you are given, since I have force and I have distance, I can also equally say that the units here can just be force is in Newton and distance is in meters. So this can also be the SI unit for work. When there's a video on dimension will help you to always know the SI unit of quantities, to know the unit of quantities if you know the dimension of that particular quantity. So this is what work is. Now, but there are some cases whereby they will give you a question and tell you that the force rather is applied at a particular angle. It's applied towards a particular angle. There's always an angle given in such question. They will tell you that the force is applied in so angle. Now, in case of such questions, you don't approach it like this. There's a different approach. Now, for instance, if I have a box, let's say I have a block or a box. Let's say I have a box. If the box is on a horizontal surface, the box has two directions. Number one, the box can either be moved towards the horizontal direction, or you can also move the box towards the vertical direction. Now, these are the only two directions you can move this box. It's either you take it like this or you take it up. Now, of course, sometimes you might want to incline it, but in this case, we are referring to the direction of the force. The force here now, you're going to have direction of the force, which is in an angle. This is the force. Now, if you have this case, you always have an angle here because the force has formed an angle for you. Now, if you have such a problem that is related to this, now resolution of this, the horizontal resolution will give you F cos theta. The vertical resolution will give you F sine theta. Now, if you do this and you are asked to look for the work done, now the work done in the horizontal direction, work done or work in the horizontal direction, that is when you decide to move this object towards the horizontal and you are asked what is the work done. The work done is going to be given as W equals F, this F cos theta, because this is the resolution of the forces. So this is now the force you have based on the angle. You resolve this, you have this. This is not for this video, but there's a way you resolve this. Now we're only looking at the questions at this moment. We are going to have a work on this, on how to resolve forces either horizontal or vertically. Now, if you have this, especially when we start talking about friction, now when you have this, you are going to discover that this is for the force. So the force times the distance, which is a distance. Now we can have this given as F cos theta, or we can use alpha, F cos theta times S. If you have the work done also in the vertical direction, the work done is going to be given as F sine theta, F sine theta times distance. So we're going to have this W equals F sine theta times S. The S stands for distance. Now, these are the basic ways you can find the work done if you are asked to calculate the work done on an object which is having a particular angle, meaning the force was applied at a particular given angle. Now, let's look at energy. Now, let's look at energy. We have energy is the capacity or the ability to carry out work. So the ability for you to carry out work, and we have looked at work. So that ability or that capacity to carry out work is what is referred to as energy. Now you must know that when we are talking about objects, we are talking about motion. Basically, we speak about two basic types of energy. Now, an object can either be at rest or an object can either be in motion. So these are the two considerations that you must understand, that when you have objects in terms of motion, is either the object that is at rest or is either the object is in motion. Now, if the object is at rest, that is when we talk about potential energy. But if the object is in motion, that is when we talk about kinetic energy. Now, we said energy. Energy is the ability or capacity to carry out work. Now, that is what energy is. Now, we said there are basically two types of energy where we are talking about motion. Here, the first one is potential energy. This is the energy. This is the energy a body possesses this is the energy a body possesses at rest. So when the object is at rest, it is having a potential energy. And mathematically, potential energy is given as PE. We have PE for potential energy. Short for it is giving us mgh, where your M stands for mass, which is mostly in kg. You also have your G, stands for acceleration due to gravity, acceleration due to gravity, which is always in meters per second squared. Then you have, lastly, you have H, your H, which is equal to height, which is in meters. Now, this is potential energy. The second type of energy is the kinetic energy. Kinetic energy, which gives us 1/2 mv squared. Now, this is the energy a body possesses when it is in motion. Now, let's have it. Kinetic energy is the energy a body, or the same thing, a body possesses when in motion. So mathematically, we also have it given, as I stated earlier, is given as Ke is equals to 1/2 mv squared. Now, where the same thing, our M is equals to mass, which is in kg, and our V is equal to velocity, which is in meter per second. Now, these are the two types of energy that we have. Said in terms of motion, when you have an object, the object can either move or be at rest. Now, we're going to go forward to look at some questions. We're going to solve some questions on energy, work. But before then, let's look at power. Now, let's look at power. When we speak about power, we're talking about the rate of doing work, or the rate at which energy is transferred. So we have power. Power is defined as the rate of doing work. Power is defined as the rate of doing work, or can also have or the rate of energy transfer. So the rate at which energy is transferred is what is referred to as power. Now, we have it given mathematically. It is given as power is the same thing as work done over time taken. So the work done and over the time taken to do the work. Now, we know that work done, because there are times that you'll be given a question and they will not give you the work done outrightly. You might not see it stated that the work done is so and so. They might just give you some terms, some parameters that will help you to calculate the work done. Now, so we have different ways of expressing this. We have work done. You know that work done or work is also the same thing as force. We have stated that force times distance. Don't forget, this one is in F, this one is in S. We present this using S. We use F to represent this, we use S to represent this. So therefore, let's use P for power. Or let's write it in full. Power can also be the same thing as, instead of writing this work done, I'll write force times distance over time. Now you can write this in a different way. You can have it as force times distance over, you can have the time here. Now look at this, or I can erase this. I can have this like this. And then you know that distance over time is the same thing as speed. So we can therefore say that power is also the same thing as force times distance over time, which is speed. Sometimes it is used interchangeably with velocity. So we can also have it like this. This is also another formula. You can use this equation 1. You can also use this equation 2. You can use this. Also, you also know that force is the same thing as mass times acceleration. That's for force times distance. So you can therefore say power. Just write it here. We can therefore say power is the same thing as, instead of writing work done, and work done represents force times distance. So instead of writing work done, I'm going to write, instead of writing, I was supposed to write force times distance. So writing force times distance, see what I'm going to write, mass times acceleration. So we have mass, let's use A. Acceleration is presented with the letter A. Present it using A. So M, mass is M. Of course, we know this as S. So let's just substitute that. I can use A or G. So we can also have it as G times S over T. This can also be a formula for calculating power. So whatever, no matter how the question comes, you can always manipulate your way towards the answer. So we can either use this equation 1 or equation 2 or use equation 3. And don't forget that power mostly is measured in watt. The unit is power is measured in watts. So most of the times they use the capital W to represent it anytime you calculate a question that has to do with you finding the power. So this is the unit for measuring power. Don't forget, we say the unit for measuring work is in joules, but I said there are other subunits. We also have the energy for measuring the unit for measuring energy. Energy is measured in joules. Energy is also measured in joules. And then we also have power. Power is measured in watts. So at the end of the question, you must always ensure that you indicate the unit of that particular